In this video we'll continue. We are now not using limit definitions of derivatives. We're using shortcuts to find first if f of x is x plus sine x, then f prime of x is going to be, well, f prime of x will be 1, the derivative of x is 1, the derivative of sine is cosine. And so that's all there is to this one. Next problem. F of x is x minus 1 over x plus 1 for all x not equal to negative 1. Then what is the derivative? So in this case we have a quotient rule. So f prime of x will be low d high, which is 1, minus high d low, which is also 1, all over low squared, and x plus 1 minus x plus 1 all over x plus 1 squared. X's are a zero pair, and we end up with 2 over x plus 1 quantity squared. Next, problem 6. If y is equal to 3 over 4 plus x squared, then dy dx is what? In this particular case, it would probably be easier for us to rewrite y as 3 times 4 plus x squared to the negative 1. And to use the chain rule here. So y prime would be equal to negative 1 times 3, which is negative 3, times the quantity 4 plus x squared to the negative second. We reduce the exponent. Then we still have to multiply by the derivative of the inside, which is just 2x. Now we can simplify a little bit, and we get negative 6x over 4 plus x squared, quantity squared, and that does it for this problem. We'll scroll down and go to number 7. With number 7, we have the derivative of 1 over x cubed minus 1 over x plus x squared. And we can rewrite this whole expression as the derivative of x to the negative third minus x to the negative first plus x squared, and we get negative 3x to the negative fourth plus 1x to the negative second plus 2x. If we want to rewrite that, it would be negative 3 over x to the fourth plus 1 over x squared plus 2x at the point where x equals negative 1. We get negative 3 over 1 plus 1 over 1, then minus 2, and we will have negative 3 plus 1 minus 2 is negative 4. And we'll go on to problem number 8. In problem number 8, it asks, at what point, give the coordinates on the graph of y equals 1/2 x squared, is the tangent line parallel to the line 2x minus 4y equals 3? Well, the first thing that we can do is we can rewrite the linear equation 2x minus 4y equals 3 in y equals mx plus b form. And we get 4y is equal to 2x minus 3, or y is equal to 1/2 x minus 3/4. So we want to find where on the graph of 1/2 x squared is the tangent line parallel to this line here. So what we're going to do is take the derivative of the y function and that just gives us x. 2 over 2, x to the first is just x. So if you want to find the derivative of 1/2 x squared anywhere, you just take the x coordinate of that, and that will be the slope of the tangent at that point. We want to find out where the slope is 1/2, or the slope is just whatever the x value is. So we set the equation x equals 1/2. This is the derivative, and this is the slope of the linear equation. And when x is equal to 1/2, then those two are equal to each other, and the tangent to the curve will be parallel to that linear equation. Now we still need to find the y coordinate, so we're going to take y would be 1/2 of 1/2 squared, which is 1/2 times 1/4, or 1/8. So the coordinates then that we're looking for are 1/2, comma 1/8. So I'm going to show on the graphing calculator how this looks so that you can make some sense of this. So first of all, let's look at the function 1/2, we'll call it 0.5 x to the second power. And then we'll put in the linear equation 1/2 x minus 3/4, or 0.75. 0.5x minus 0.75. And then I'll go in and zoom standard, and we'll take a look at those two. So if I wanted to zoom in just a little bit there, zoom in, notice that the cursor is flashing at the origin. If I hit enter, it zooms in around the origin there. So you can see that I have this curve y equals x squared, 1/2 x squared, and then I have the line 1/2 x minus 3/4, and I want to find out where the slope of the tangent line is parallel, and we said it was at about x equals 1/2, and that makes perfect sense there. Now I'm going to go in and draw the tangent line so you can see this. Do second, draw, come down to option 5 to draw a tangent line, and I want to draw it when x is equal to 0.5, and watch what it does. It draws the tangent to the curve, and look, it's perfectly parallel to the linear equation. Right? So hopefully that makes that clear. But the process is pretty straightforward algebraically. We're going to take the derivative of the curve, the derivative of 1/2 x squared, and we're going to find the slope of the straight line of the linear equation. We're going to set the derivative equal to the slope and solve for x. In this case, we didn't have to do any solving because the derivative was just x. But normally, we'll find the derivative, find the slope of the line, set the derivative equal to the slope of the line, solve for x. That tells us where the derivative is, or the slope of the tangent line is parallel to the straight line. And that'll be it for this video.